Good evening, students. Today we are going to learn about the chapter called atoms and molecule. So in this chapter we have to learn about what is the atom, what is molecule, how these atoms combine to form the molecule. So the law governing the formation of compound is called laws of chemical combination. So we have to learn about laws of chemical combination. There are total 5 laws of chemical combination, but at your level you have to learn about the only 2. So the 2 important laws of chemical combination are laws of conservation of mass and laws of constant or definite proportion. Okay, or means the law of constant proportion, or you may call this law as law of definite proportion. So these are the important laws that we have to learn. Later on we will also learn about the atom, how the atom composed of, what are the various theories that was proposed to explain the combination of atoms to form the molecule. Those theories are called as atomic theory. So we will learn about the size of atom, how these atoms combine to form molecule, what is the mass of atom, called atomic mass. Then atoms combine to form molecule. So we have to learn about how is the molecular formula. Then molecule also have the mass. So molecular mass. Then while this molecule is formed, atom have to first either form the ion or have to share, means they have to combine. So most of the combination occur by formation of ion. So what is this ion that we will learn? So this ion could be your cation, means positive ion called cation, or negative ion called anion. So this thing we will learn. So let us start. We are knowing that matter is what? Anything that occupies a space. Consider this is the pen which is available in my hand. If I start breaking this, means destroying this, breaking into 2 pieces, then each pieces or one of the piece into the another 2, one of that a smaller piece into another 2, means breaking very smaller part, means to the smallest extent that you can break a matter. So that smallest part was called as Pramanu by Indian philosopher Maharshi Kanad. So he had given this theory about 25 years back, around 500 BC. We are in 2000 AD. So this 2000 year plus 500 year back. Means 2500 years back, our Indian philosopher has proposed that the matter consists of a smallest particle called Pramanu. Later on, with the development of science, it appears correct, and the theory was proposed by Dalton. When he started dividing the matter into smaller pieces, he reached to the smallest particle which was not further divisible, and he called this smallest particle as atom. So atom means indivisible simply. He proposed that these atoms are indivisible particle for a matter. If these atoms are divided further, then matter will not be there. This was the proposition of Dalton. It was called as the Dalton's atomic theory. So that we also have to learn. Now these atoms combine to form molecule. This formation of molecule from the atom was observed through various experiments. Then scientists started searching how these atoms are combining to form molecule, means how these atoms are combining. So they observe certain rule. So that rule was called as laws of chemical combination. So these laws of chemical combination was proposed by two scientists called, one called as Lavoisier, another is called Proust. So it was the Lavoisier and Proust who proposed that atoms combines to form molecule, but they are following certain laws. And they proposed that there are two important laws. One is called law of conservation of mass, another is called law of constant proportion. So these two laws have to be followed by the atoms to combine to form molecule. Means element combine to form compound. From the element, the smallest particle is atom, means atom of the element combine to form molecule of the compound. So while forming these atoms or elements combine by following these two laws called law of conservation of mass, another is called law of constant proportion or law of definite proportion. So what these are, these things we have to learn. So student, very first topic is law of chemical combination. What this tells? The name itself tells it is the law which is governing the chemical combination. Chemical combination means atoms combine chemically to form entire new kind of substance called compound or molecule. Molecule is the smallest particle of the compound. So what are these element? What are compound? Those things we have learned in last chapter. You may go through those videos. So student, so chemical combination means combination of atoms. So this tells or it gives how atoms or elements combines to form compound, molecule, and the substance obtained or pure substance obtained by this chemical combination is called as compound. So this law of chemical combination tells how these atoms will combine to form the molecules. So those things. So how is this combination? Those things we have to learn. Then it was stated by the scientist that there are certain laws which are followed. So right, following are laws of chemical combination. Means the chemical combination itself consists of 5 laws. Chemical combination. The very first law is called law of conservation of mass. Right? Law of conservation of mass. What is this? We will learn in more detail. The next one is our law of combination, law of constant proportion. Write down the second one. Law of constant. Constant simply means fixed. Sometimes also called as definite. Law of constant proportion. Proportion means ratio. This law of constant proportion is also called as law of definite proportion. Definite term means something fixed. So what are these laws of constant proportion? Laws of conservation of mass. These two laws we have to learn, and these two laws we will finish today. So write down the first law. The first one is called as law of conservation of mass. So what this law tells that mass, the same mass, whatever we have learned in our physics, mass always mean the same thing. So what this law tells that during a reaction, mass doesn't get changed. So it is called as mass can neither be created nor be destroyed. So the law is like this: mass can neither be created nor be destroyed. In a chemical reaction. So it is talking about during a chemical reaction. In a chemical reaction. Means if we consider a chemical reaction, then total mass always remains the same. So how is the chemical reaction? A student, if you are taking the carbon, say wood that you are taking is also a carbon, and you are burning it. Burning it means it is combining with oxygen. So carbon, while it is burning, it can give you the gas or the new compound called carbon dioxide. It is observed that 12 gram of carbon can combine with 32 gram of oxygen to form 44 gram of carbon dioxide. Means if we consider the total mass which is going to react, so this side means the compound which are reacting, they are called as a reactant. So these are the reactant, and the side which is formed after the reaction, it is called as product. Then if we consider the total mass of reactant, total mass of reactant, how much? So reactant consists of two kind of substance. One is carbon, another is oxygen. So carbon 12 gram, that is going to combine with 32 gram. So total become 44 gram. So reactant means the substance which are combining, that is 44 gram. And total mass of product which is formed. So just you have to watch on the product side, it is also 44 gram. So what we can write from here? It simply means the reactant mass or the total mass of reactant is always equals to total mass of the product. So it is written like this. See, total, therefore total mass of reactants is equal to total mass of product.
Sir, can I explain one more time that?
Yeah, see, let me explain once again how I have came to this conclusion. Student, you please watch the last thing. Law of conservation of mass. This law states like this: mass can neither be created nor be destroyed. This is the simple law. Okay, but how this law is arrived, how we come to this conclusion, that we want to understand. For that, during the experiment, carbon was taken and oxygen was taken, and the reaction was carried out. Carbon and oxygen reaction means burning. It was simple burning. It was observed that if 12 gram of carbon is taken, it is going to burn with 32 gram of oxygen. Then after burning, the new compound formed was carbon dioxide, though it was in gas form. So this carbon dioxide, the mass of carbon dioxide was measured, and it was found that the mass of carbon dioxide is 44 gram. So this was the experimentally observed data, whatever I have written. So carbon, C stands for carbon, O stands for oxygen, but oxygen always exists as O2. So we are writing O2. Why O2? Why not O? These things we will learn later in this chapter. Then it was observed that this carbon and oxygen combine to form a new compound, carbon dioxide, and the formula for carbon dioxide is CO2. It was observed that the mass of CO2 is 44 gram. The substance which are reacting or which are combining is called a reactant. So reactant are, one is the carbon and other is the oxygen. And the substance which is formed after the reaction is called product. So the product here is our carbon dioxide, only one of the product. So if we consider the total mass of reactants, means it will be the mass of carbon plus mass of oxygen which are reacting. So mass of carbon is 12. So for calculating the total mass of reactant, it is 12 plus 32, it becomes 44 gram. Now consider the total mass of product. See, in product we have only one substance, then total mass will be the same. No need to change that. So total mass of product is already 44. So that we can write here. Here we are observing that total mass of reactant is 44 and total mass of product is also 44. So what we can conclude from this? Both are 44, right hand side. It means the total reactant mass is equals to total product mass. That can be written. So this reactant and product term itself indicate it is during the reaction. Yes, Pratna, your mic is on. Please off it. So student, therefore, the reaction can be written or the conclusion can be written like this. The mass of reactant, the total mass of reactant is equals to total mass of product. Here each was equals to 44 gram that we have just observed. It means what? During the reaction, the mass have not changed. That was the conclusion. So right, that is the other way of stating the same thing. So during the chemical reaction, during chemical reaction, the mass remains unchanged. Remains unchanged. Means the total mass, basically, better to write the total mass remains unchanged. Means if we are considering the total mass of reactant, that will be equals to the total mass of product. Getting? So this is the other form of stating the laws of chemical combination. That is sometimes also stated like this: there is no change in mass of the substance, means the total mass basically. So there is no change in mass when a chemical change or when a chemical reaction occur. When a chemical reaction occur, whatever we are writing, say carbon and oxygen combines to form carbon dioxide. It was observed 12 gram of carbon combining with 32 gram of oxygen to forming 44 gram of carbon dioxide. So writing this combination means the chemical changes, it is called as chemical reaction. Before the arrow, this is the arrow which indicates the change or chemical change. Before the arrow, whatever coming, these are the reactant. And whatever formed after arrow, this is the product. So total mass in this case means the sum is our 12 plus 32. It is our 44 gram. On product side already 44 gram. So this way we are observing these two mass are same. So it simply means so no change in mass. Getting a student? This can be verified in our experiment or in our laboratory. So you may write lab verification. A student, in laboratory you have to take the compound, mean the two compound, because this chemical change can be observed by changing their color or some other criteria. So you take the two compound. Let us take one as the copper sulfate, like carbon dioxide, oxygen, whatever we have taken. The compound that we are taking is copper sulfate, and the other one is our sodium carbonate. A student, you take it. You take this copper sulfate in a test tube. The test tube is like this. You take this. You take this sodium carbonate in larger amount, the solution of sodium carbonate. Take it in a jar. Let me draw the conical flask for better understanding. See how the reaction setup is there that I want to explain. So this is the conical jar where you have taken certain amount of calcium carbonate. It is taken here and sodium sulfate is taken here. Okay, student, it is taken. Now we have to carry out the reaction. If I now put this inside this, it may be possible that certain gases are formed and it is able to go out. Means the gases cannot be trapped. So therefore, a setup is made such that it is initially placed inside this in a closed compartment. So you just take certain mass. You may consider the total mass of this and this. You may consider this as X and this as Y. Initial measurement will be your X plus Y. That will be the total mass. X is including your mass of tube. It may be possible, as well as the mass of the copper sulfate. For carrying out the reaction, it is placed, this tube itself is placed inside this conical flask. So this setup appear like this. So this setup is like this. Student, let us place this tube inside this. So tube is arranged in such a manner that the chemical is not falling in it. It is up to this much level, we may consider. And the inside the conical flask, the other chemical, let me denote it by blue color. Okay, student. So the chemical in conical flask is initially not mixed. So let us take this both in such a way. Means it is carefully placed. So for placing this arrangement, we need to put some tag or tie here. Means there is certain hook in this, like your mug, such a tube, and it is tied here, and this is being closed. So closed means the thread you may take. So it is a stop cork or lid, or the stop cork is there. This is our tube. Inside this tube, it is the copper sulfate, but this is our conical flask. This is our flask or conical flask. This is our tube. Now this is the weight of this is measured when the two are separated. Okay, means one is placed inside the other. Now the total weight is found to be x plus y. Okay, x of tube, y of this. The total weight you put on the weighing machine or weighting machine, it will weigh. Now after some time, this is tilted. How this tilting is done? This conical flask is tilted such that the tube, whatever the chemical in this tube, that will just pour into, or that will just mix with this one. So that we have to do in next question, students. So let us take like this. So draw the other question, I mean the other figure, in which the conical flask is again taken. This end is packed. Now this is such that this tube become empty, and both the copper sulfate solution which was inside the tube as well as the sodium carbonate solution which was already inside the flask, these two have mixed. So you will observe that in this case the blue color, this copper sulfate is basically blue in color. So this blue color will get faded, and some green color and some other kind of fume is produced in this. So certain fumes are also produced in this. So therefore it is kept closed. Now after this, the color have changed. Means this color will no longer be blue or no longer be only yellow, but it will change. This is again weighted. So you weight it again. This was the initial weight which was done, and it was found to be x plus y. While weighting again, you will find that again the weight remains the same, x plus y. So this was the experimental setup which was carried out, which tells that the mass remains unchanged during the chemical reaction. How it is confirmed the chemical reaction had happened? by change in the color, by mixing of this tube content in the content or the solution of sodium carbonate in the flask. So right, so it was observed that, so it was your initial, and this is the final, means finally after tilting the weight is taken. So the weight, it is basically the mass we shall write, not the weight. So weighing machine we are calling it. So the mass remains unchanged. So this was just the conclusion that was drawn from this experiment. What was this experiment? Two compound, one is called as the lead sulfate, another is sodium carbonate. They were taken in two different kind of setup, one in the tube, another in the conical flask. One was placed inside the other carefully, but not the mixed one. Then the weight was measured. It was observed as X plus Y. Means total weight may be your 500 gram, 1000 gram, whatever may be. Now, this conical flask is tilted. Since it is packed or it is closed with the stop cork, so the chemical will not come out. But the chemical inside the tube, that will mixed with the chemical in the flask. Then again the weight was measured. It was observed that the weight remains the same, but the color of the compound in the conical flask and the tube was changed. That shows that chemical reaction had happened. So this way it was confirmed. Here I have taken two compound, one as the copper sulfate, another is the sodium carbonate. One may also take the other pair. One may take the pair like your barium chloride. What these chemical are, these things we will learn later. What are their formula? So the other pair could be barium chloride, and with barium chloride you need to take sodium sulfate. The other person may take the other pair like your, let me write down the third one here. Means this is the pair. Either you take the first pair only, as I have explained, sodium carbonate and copper sulfate, or you may take the second pair, say barium chloride and sodium sulfate. Why this in pair? Because these two combines to form the precipitate or shows the color change. That's why a specific pair is always taken. One may choose the pair like lead nitrate, and with this lead nitrate you have to take the sodium chloride. So either you take the pair copper sulfate with sodium carbonate, or you take the pair barium chloride with sodium sulfate, or you take the pair lead nitrate with sodium chloride. These are the three pairs that you can choose, and you can do this, this setup or this experiment with any of the pair. Though with the first one I had explained, you have to take in one in tube, another in flask. You have to wet it after mixing the two, and one is before mixing the two. You will observe that the weight after mixing is same as the weight or the mass before mixing. So this way we can verify that this law of constant or law of conservation of mass is followed during the chemical reaction. So it was one law. Now let us go for the second law. Any student have any doubt, then please ask. These are important things. What is law of conservation of mass? That you have to keep in mind. During a chemical reaction, total mass always remains the same. So in equation form, the total mass of reactant is equal to total mass of product, or in a statement form, there is no change in mass when the chemical reaction occur, or in general form, you may state like there is mass can neither be created means nor be destroyed, means it always remains the same. So mass remain as it is. So these are the three ways of stating the conservation of mass. So it may be asked in any of the three ways in MCQs. You have to choose the correct option. Now let us go for the second one. Second one is our law of constant proportion. So this we will learn. So right, the second one is our law of constant proportion, or this is also called as law of definite proportion. Definite means something fixed, proportion means ratio, sometimes also called as law of fixed proportion. In place of proportion, sometimes also called as proportion, simply means ratio. So the term ratio may be written there. So what this law tells, so both the laws were stated by or given by the Lewis and the Proust. So that you have to keep in mind, who have given these laws of chemical combination. Sometimes it is also asked. So what is this law? So what this law tells that if you are forming a compound from the element, then element always combine in fixed ratio to form particular compound which have particular composition. Means if you are taking say H2 and you are combining with the oxygen, it will form the water. So the water always contain two atom of hydrogen and one atom of oxygen. So this water always contains two atom of hydrogen, which is denoted by H. Here this 2 which is in suffix, it represents the two atom, and one atom of oxygen, denoted by O. Though hydrogen itself exists as H2, it is the two atoms. It is one atom, sorry, two atom of what? It is of oxygen, student. It is two atom of hydrogen, student. So these two atom of hydrogen exist in the combined form. So it is your one molecule of, so whether it is written as two atom of hydrogen or one molecule of hydrogen. Means one molecule of hydrogen contains two atom of hydrogen. It is two, this O2, so it is two atom of oxygen, or you may write this as one molecule of oxygen. means one molecule contain these two atoms. It may be your triatomic or the single one. Those things we will learn later in this chapter called atomicity. Like oxygen may exist as O3 in ozone. So those things we will learn later. So what this law tells that here hydrogen and oxygen have combined to form water, but this water which is formed will always contain two atoms of hydrogen and one atom of oxygen combined to form water, which always contains two atoms of hydrogen and one atom of oxygen. So irrespective of the method used for preparing water, whether you are preparing this water in laboratory or whether you are catching the water from the rain, so irrespective of the source of water, it will always contain two atoms of hydrogen and one atom of oxygen. So irrespective of source. It simply means water. In the similar fashion, we may take the other chemical also. Water means H2O always have hydrogen and oxygen. So if we are talking for water, means it will always contain the two kind of element, one as hydrogen and other oxygen. And this hydrogen and oxygen will present in fixed ratio only, and their ratio is 2:1. That is, if you are taking the number of hydrogen atom and number of oxygen atom, this is always 2 times 1. So if we are talking for water, water always contains here 2 hydrogen atom and 1 oxygen atom. Nothing below the oxygen means it is 1. Default one is 1. Say if you are changing, if in place of H2O, if you are writing taking like this, it is not water. It is not water, but a new compound is formed. Means if the ratio is changed, though the combining element remains the same, so not water, so a new compound. This new compound is called as hydrogen peroxide. This you will learn in higher standard, so no need to mug up or write here. So it is different, so it is not water. Get it? Means for forming the water, the hydrogen and oxygen should combine, and this combination should always be in fixed ratio. So this was what the statement of law of constant proportion or law of definite proportion. Here this is always fixed, means it will always, so that's why it is called as fixed ratio or fixed proportion. So this ratio is always fixed. Therefore this law is stated that in a chemical reaction or in any chemical substance. What is the chemical substance here? It is the water which is formed, or hydrogen peroxide. So in a chemical substance, the elements are always present in fixed proportion. So right, in a compound or chemical substance, or better term is compound, the elements are always present in fixed proportion. Fixed, or we may use the definite. Definite simply mean the fixed or constant ratios. So the term ratio is also called as proportion. So this is the law. You may state in this simple word, it is also okay, or you may write the complete statement like this. So compound, so this statement you have to keep in mind. So compound always consists of a compound always consists of two or more elements So this means any compound you are taking, it will always contain two or more elements, and these elements combine, which combines or which is present in fixed or definite ratio. So ratio is sometimes used the term as proportion. So in definite proportion. So means the compound always consists of two or more elements, and these elements have to be present in fixed or definite proportion, irrespective of whatever the method you are using to obtain that compound. So irrespective of, right, irrespective of the method of obtaining that compound. So student, it's very simple. So you have to just take any one of the compound. Example, whatever I have taken here. So water, if I talk about the water, then water always means H2O. So it contains what? Hydrogen and oxygen. So these two are the element present. But this oxygen and hydrogen, presence of these two will not always form water. So these two have to be present in a fixed ratio. Means number of hydrogen and number of oxygen atom, if you are counting, then hydrogen atom and oxygen atom must present in the ratio of 2:1, means 2 hydrogen and 1 oxygen. So these things have to be followed. If the ratio is changed, then So this ratio have to be maintained. If this is changed, then it will not be water. So if hydrogen and oxygen are taken in the ratio of 2:2, or simplifying this, one may write 1:1, then the molecular formula becomes, see, hydrogen is occurring 2 times, so we have to write H2. Oxygen is also occurring 2 times, so below O we have to indicate the number of atoms, so H2O2. So it is not water, but it is called as a new compound called hydrogen peroxide. Hydrogen oxide. This you will learn in higher study. If you are taking the other one, say the carbon dioxide, the first I had explained this. If we are taking, say, carbon dioxide, if I say the term carbon dioxide, means the carbon and oxygen have to present in such a ratio that carbon should be 1 and then oxygen should be 2. Means 1 carbon atom have to be combined with 2 oxygen atom. So the molecular formula become carbon 1 time, so 1, oxygen 2, but 1 is not written, so this can be dropped and we can simply write this as CO2. Means it is simply CO2. Is it okay? Say if we change this, so we are taking 1 carbon and 1 oxygen in 1:1, that is the formula becomes C and O. So this is not carbon dioxide, it is a new compound called carbon monoxide. Are you getting a student? So this law of chemical combination simply tells that if you are considering any particular compound, then its composition is always fixed. It will always contain particular kind of atoms in particular ratios. If the ratio or number of atoms are varying, the compound will differ. Or if one of the atom is changed, then the compound will differ. Example, here we have also observed, say the oxygen is same, but hydrogen is now going to add with it in the ratio 2:1. It have formed H2O. It was our water. Are we getting? Though oxygen was same here. So this way, for particular compound, the element have to combine, means the particular kind of element have to combine, and their combination should always be in fixed ratio. So this was all about our laws of chemical combination. So student, this thing you have to keep in mind. So both these laws of chemical combination and laws of constant proportion are very important. So how these two things are written over a reaction? Let us consider a reaction. Say the reaction is our H2 combining with O2 to form H2O. Because we are knowing that irrespective of amount of hydrogen ion present or hydrogen molecule or atoms present in reactant, the product will always be H2O. So here we are observing that in term of number of atoms, it is your 2 hydrogen atom. It is our 2 oxygen atom. But for water, there is 2 hydrogen and 1 oxygen atom. But as per law of conservation of mass, the mass of reactant should be equal to mass of product. It means the number of atoms in reactant should also be equal to number of atom in product. Here we are getting hydrogen and hydrogen, they are matching. But here, considering the oxygen, oxygen is 2, but on the product side or on the right hand side, it is 1. It means we need to increase this because O2 cannot be reduced. So you need to increase this oxygen. Increase oxygen. For increasing this oxygen, you will put a new number. That new number is placed before it. Means this oxygen have to be increased too. So you cannot put it here too. Otherwise, it will represent hydrogen peroxide, a new compound, rather than water. We have to maintain it water. It means the 2 cannot be placed at the end. So how to place it? For placing it, we are putting the number before this water. Therefore, 2 have to be placed before this. While placing the 2 before this molecule of H2O, it becomes like your 2 water molecule. Water molecule. But while making this 2 water molecule, number of hydrogen atom, that will also increase, because this 2 is for this hydrogen as well as for this oxygen. Therefore, in this case, the oxygen have become 2, but at the same time, the hydrogen, already the 2 is here, that is also multiplied by this 2, it becomes 4 atoms. So 2 water molecule, it means it have 2 oxygen atom and 4 hydrogen atom. But is this 4 hydrogen atom present in reactant? No. Student, here we are observing that 2 oxygen atom, it is okay. But this is 4. To balance this, I need to increase this. So for this, we are putting the the prefix 2 before the hydrogen to increase it. Get it? Therefore, the final equation is like this. After placing this 2, here number of hydrogen atom become this 2 as well as the suffix 2. So it becomes 4 hydrogen atom. So this way, considering the equation, 4 hydrogen atom on reactant side, 2 oxygen atom on reactant side, and on the product side also we have 4 hydrogen and 2 oxygen. But this 4 hydrogen and 2 oxygen is present in the form of 2 molecule of H2O. Here this 2 oxygen is present in the form of O2 and 4 hydrogen is present in the form of 2 molecule of H2. It is like this. Now considering the mass, it is found that the mass of the hydrogen is 2 gram. So it is 2 gram. Combining with this 16 gram, this O2, if you calculate the mass of this O2, means H2 is only your 2 gram, student, but this is our H2. But if I consider basically the idea of atomic mass that we will learn later, with that this hydrogen, one of the hydrogen atom have mass 1 unit and it is occurring 4 times. So it is total 4 gram. This we will see later. It is after this topic. So 4 gram of hydrogen that have combined. It is found that this oxygen, one of the oxygen atom have mass 16 gram. Since O2 is there, means 2 into 16, it means it is our 32 gram. So it is found that this 4 gram of hydrogen is combining with 32 gram of oxygen. So keep in mind this 4 gram of hydrogen, 32 gram of oxygen to give the water molecule that we are obtaining here. Its mass is measured and it is found at 36 gram of water is formed. Are we getting this? So this way, the total mass of total reactant mass is your 4 plus 32, it is your 36 gram, and total mass of total product mass is already it is your 36 gram. So this way, law of conservation of mass is also followed, and holding the 2 and 1, the ratio of hydrogen and oxygen in this water molecule, the law of constant proportion is also followed. So both these law have to be followed during any of the chemical reaction. So this was all about laws of chemical combination. Student, any doubt, then please ask. Otherwise, you read this topic from your book as well as go through these videos. These are helpful to you. Then only you can understand what do we mean by all these things. It is very important. So this way I had explained and I have finished the first topic called laws of chemical combination. So this topic we have finished. Next day we will start. After this, what is atom? What is Dalton's atomic theory? Those things we will finish. Then how these atoms are combining to form the molecule, those things we will finish in our next class. Student, any doubt in today class, then please ask. So student, now your homework, please read your textbook